Okay, in this video, we kind of pick up from where we left up on the previous video that just kind of reviewed the different transformations of quadratics. Now we're going to apply this understanding to all various different functions. So let's go. In the previous video, we saw all these different parent functions and how each parent function could be written with the a, the h, and the k. So we saw that all of these parent functions had the same three characteristics. The a was a coefficient, a number multiplied, and the h and the k were numbers that were added or subtracted, so constant terms. The h was a number added or subtracted inside a grouping symbol, and the k was a number added or subtracted outside the grouping symbol. So what we're going to first focus in on, let's first play with the h's and the k's. As a reminder, the h was movement left or right, so what was added or subtracted on the inside caused the graph to move left or right, and the k, which was added or subtracted on the outside of the parentheses, caused the function or the graph to move vertically, up or down. So got a few graphs to kind of sort of help us discover and see that these impacts are the same as what you understood for quadratics. So the first one I'll look at is the absolute value. So y equals the absolute value of x is this v shape. And so if I was to take this graph, the parent function, and begin to add or subtract on the inside of the grouping symbol. Inside for quadratics made it move left or right. So if I simply added 3 on the inside, there we go, and it moved 3 to the left, just like we discovered with the quadratics. Anything that we added or subtracted on the inside caused it to move left or right, and it went the opposite of what you anticipated. So if I would have just added 1 to the left. If I subtract, say 3 to the right. So again, to emphasize that when we add or subtract on the inside, no matter what the picture looks like, the impact is going to move left or right. So let's look at moving it on the outside. So if I add or subtract on the outside, we saw before, it makes it move vertically. So if I added 3, it does make it move up 3 units. Subtract, say minus, 2. It does move down 2 units. So again, just to emphasize, the movements, the transformations actually aren't just for quadratics. It applies to any one of our functions. So let's look at a different one. Let's look at the rational. Under the rational, these two little curved looking pictures. So again, if I took the rational function, and here the bar, the little division bar, is our grouping symbol. So when I do something in the denominator, technically this adding 3 is inside of a grouping symbol. So inside the grouping should make it move left or right. Here, plus 3 should make it move left. And in fact, it does. So the entire picture just moved 3 to the left. 3 to the left. So if I subtract it, say minus 2, it makes it move right 2 units. So again, you're not so much concerned about the shape per se. You're translating this, an understanding that when you do something inside of a grouping symbol, the impact is the same as it was for quadratics. So if I take it on the outside, say plus 2, the entire picture did move up 2 units. On the outside, minus 3, the entire picture did move down 3 units. So again, all of these actions are transferable. Let's go ahead and turn these off. And let's practice it with the exponential. So with the exponential function, 2 to the x was the parent. Exponent. The x is the exponent. The x games makes this ramp looking figure. So what one has to understand is, where is the group? The group here is with the x. So when I add 3 as part of the x in the exponent, that should make it move left 3 units. And in fact, it does. So it's kind of tough to see, but definitely there's a left movement here. Again, if I subtract, say -4, moves to the right. Let's do it now on the outside of the parentheses. So I take it all the way out, back on the same level as the 2. Say +3, the entire picture did move up 3. -1, the entire picture did move down 1. So I think you're starting to see the critical part is knowing where is the grouping symbol. All right. If we looked at radical, obviously the grouping symbol is part of the bar on the square root symbol. Reminding that radical function does make this shape kind of similar to the square root symbol itself. So underneath the radical, that's our grouping symbol, the bar here. And so here to the left 3, of course if I subtract, it'll go to the right. -2 makes it go to the right. Now when I place it on the outside of the radical, if I do +2, there's going up 2 units. So again, the idea is understanding where is the grouping symbol. And what's under the grouping is left, right, and you do the opposite. On the outside is up and down, and you do what you see. You see it went up, up appears to be positive. All right, almost there. Cubic. Y equals x cubed. Make this little squiggly looking shape. So the same thing is going to happen. Let's say on the outside, I work with the outside first. So if I add 2 on the outside, this entire picture should move up 2 units. And it does. It started at the origin, up 2 units. Obviously, if I subtract, -1, it does move down 1. Now let's play with the inside. So I'll create parentheses here. So open parentheses, x, let's say +1. You should expect it to move to the left 1 unit. So again, it's all about understanding where is the grouping symbol. So now, let's work with something a little bit out of the ordinary, some of our trigonometric functions. And so what I'm trying to emphasize is regardless of what the function is, the transformations are the same. So this is what the graph just happens to look like. Don't be concerned about why it looks this way, but just understand, okay, it just happens to make this roller coaster looking thing. And so if I was to take the same situation and let's add inside the parentheses. Let's see what it looks like. Well, it's hard to tell that it moved or whatever. Definitely it didn't go up and down. So right now, the h looks like it is +4. So here's what I'm going to do. I'm going to turn this one on. Right now, this is the exact same as the parent. So I'm going to move that h to +4. And as I move it to +4, 1, 2, 3, 4-ish, you can see the picture is moving left and right. So that x +4, so as you can see, it does move it left and right. Bet. So if I turn this off, let's go back. Now let's, did I do something I didn't want to do? I did. So let's do this. If I add, say +5, as you can obviously see, it did move it up and down. So what we'll do is go back here. All right, so that helped us to see what was happening with the h and the k. Let's talk about now the a's. All right, to recall, if a was greater than 1, it was a stretch. If it was between 0 and 1, it was a compression. And if it was negative, it made a reflection. So I'll just do a couple of them. I did absolute value. All right, there's our v again. And so here, if we make a, say a 5, because it's greater than 1, we should expect a stretch. there's our stretch. If it was, say, 1/5, there's our compression. So again, with any one of our functions, the same occurrence will occur. Let's try it with a different function. Let's do, we'll do the exponential. Let's go down, rational. All right, same situation. There's our picture. So now let's see what a compression and stretch would look like. I'm going to put the 4, so we should expect a stretch. Let's see what a stretch looks like. There's a stretch. Like, that may not look like a stretch to you, but it's a stretch. Let's compare it to 1/4 compression. So you can see it's being pushed in. So there's our compression being pushed in. And of course, if I made it negative, everything flips. And again, it's kind of tough to see how this reflects, but trust me, it does actually reflect. All right, let's look at, so exponential, same situation. We'll jump to the more advanced one. So back to the y equals sine x. And so what we're going to do is see what a compression and a stretch looks like. So 4. We definitely know this is supposed to be a stretch because it's greater than 1. That's what a stretch looks like. So it looks like from here, we stretched out that way, and from here, it's stretched down that way. Now, you can't assume that a stretch means it goes up. No, it just stretches. So if I actually did this, turn this one on. So if I start to change my A, you can see how that's what a stretch is doing. It's stretching it, stretching it. And then we'll look at what a compression does. So that's back to the parent right there. Now, if A is 1, now if it was, I'm going to move it 0.9, 0.8, 0.7, so you can see it compressing, compressing. And as soon as I get to the negative, it flips over. So a negative stretch, a negative compression. All right. So hopefully this is bringing some clarity. So let's go back to the PowerPoint and do a couple problems. So we looked at this example. Again, what you're not concerned about is this radical. You're looking at where are my numbers. I have a number on the inside, a number on the outside being added or subtracted. So in this case, the A is -6, the H is -3 for all practical purposes, and the K is -4. That -6, so the negative tells you it reflects, the 6 lets you know it's a stretch. That -3 says we're going to shift 3 to the right, remember the opposite direction. And the 4 tells us we're shifting down 4 units. Another example, again, you don't want to be distracted. You just recognize, okay, I have a number being added in a group, a number being added outside the group. So my A is a half, my H is the 5, and the K is the 1. Well, that A is going to cause a compression. The 5 on the inside is left-right. That's a left shift. So we're shifting 5 units to the left, while the K shifting 1 unit up. A couple more examples. All right, we have an A. It's -3 5/9. There is no H because there's no grouping symbol. And the K is 8. So the A, the negative, tells us to reflect. The 3 5/9 is a number larger than 1, so there's a stretch. Because there's no H, no horizontal shift, and of course the K will make it move up 5 units. Last one. We have an A. We do have an H because we do have a grouping symbol, and there's no K. So the negative tells us to reflect. The 0.32 is a compression because it's between 0 and 1. That -6 is inside the parentheses, so shift 6 to the right, and there is no vertical shift. So hopefully this will bring some clarity to the different transformations, how it applies to other functions.